Hi, good afternoon. I'm going to talk to you about a research project we have been working for the last 2 years. I'm going to present some of the results we have for this project. Here's the agenda, but I'm not going to use this with this. Okay. The point with this project is Costa Rica has a digital signature law since 2005. But by 2014, the Ministry of Technology emitted a directive, this is the Directive 67, asking the government institutions to provide online services for digital signature. And they set a time frame of 3 years to launch some of the services. So the point here is that Costa Rica already have some basic relevant infrastructure, such as the certificate authority, what is the main element of the system for digital signature. And we already have digital certificates like this, okay? But we don't have many applications. We have some applications, and we want to have many because, we don't want to go to the crowded city and waste our time in the car. It's like easier if we can do some operations from home. So the point here is that we don't have regulations, appropriate regulations for quality and security of information for digital signature solutions. So after this directive, we talked to the Ministry of Technology, and we talk also to the central bank to help with the process of massifying the digital signature solutions. And if you're wondering why the central bank, that is because in Costa Rica, the central bank has the infrastructure and the resources to host the certificate authority. So that sounds interesting, but that is true. So we have started working with them to create the guidelines and the regulations so we can guarantee to the citizens that they have the appropriate solutions to use from home. And we started with some initial review. We reviewed several countries, such as Spain, France, Brazil, Belgium. This is some large list of countries. And we found that many countries are having solutions similar to what we want to do. And for example, in Spain or France, they have profiles, like security profiles, protection profiles, to assure the software applications. And for example, Brazil have some proprietary or their own solution for the software applications. And we also found that the European Union, okay, with some proposals. For example, they provide open source. They don't have like a very strict set of standards for assuring the solutions, but they provide open source. So what we learned from this initial review is that, okay, we are looking for similar goals. We also identify some relevant information that we should consider in our process. And also we found that assuring the information for digital signature solutions is a requirement. And maybe the last lesson we learned is that we cannot adopt any existing solution if we don't know what we want to do. And that is almost true for everything in life, but I think that's an important fact. So we said, okay, we have to start defining what we want. And then this is our approach, okay? We cannot provide security for everything, so we defined use cases. It's like the scope, the scenarios where we want to provide some security related to the digital signature scenario, okay? And having clear what is this scope for the use cases, we started looking for some methodology or process to do risk analysis and for security policy definitions, and then to define what we call the control objectives. These are like the security controls, but if we want to do regulations for the entire country, we need something that is more general, that's some security control. You know, we cannot just specify like very technical and specific ideas, because people is going to implement the systems in very different ways. And we said, okay, these are going to be control objectives. And at the end, we come up with some certification schema. You know, it's like maybe the technical part and some other aspects, probably related to the organization and regulations, additional to the technical aspects. And this is the overview of our process, and I'm going to detail some of these points in this presentation. So first, we identify 4 relevant use cases, because, as I said, we are not going to focus on everything. It's just the digital signature scenario. So we decided to focus on digital signature creation, digital signature verification. You know, this is the basic stuff. And then we are going to focus on authentications to come into to log into the systems when we want to use the digital signature. And we have one more case where it's basic to advanced format conversion. The point here is that we have 2 types of digital signature. One is we call the basic because you sign the document, but you don't have a timestamp to say when you signed the document. So the advanced format is when you add the timestamp. You know, it's a certified timestamp saying when you sign the document. So because we already have both types, we need sometimes the conversion from basic to advanced format. So I'm going to pick the first use case to explain some of the details that we use in our model. Okay? This is a picture showing the steps, because you know we have to be very general. You know, it's like we are going to audit many different applications, but they have the same behavior. So we have to extract the essential part of the process. And then I said, okay, what we have to do to sign a document? And here are the steps. It's like you pick the document, and then using a hash function, you get a summary of the document. Maybe I can show you here the mouse. Yeah, okay, and you get here the summary, and then you are going to encrypt that summary. This is the signature of the document, and then you are going to put this signature together with the certificate that you have to validate against the certificate authority, and you have to put together to get the signed document. You know, this seems to be easy, but it takes a while to come up with the core ideas of the process. And we did the same for the other use cases, because as I mentioned, our idea is to come up with a general process. So after that, we started thinking about the different architectures where these processes are going to be implemented. And we have a lot of cases, you know, like here I am showing just 2. It's like, what happens if I have a standalone application where everything is running inside the same host? You know, the document is here, the certificate is here, the process, the whole application to get the signing process executed in the same computer, and even the private key, you know, is connected probably with a USB cable using a reader, okay? And on the other side, we have, for example, a client-server application. You know, this user is at home. This is maybe a governing institution having a server, and we want to ask this server to sign a document, and probably the private key to sign the document is over the network stored in this security device. So are the risks the same in these two processes? Because the signing process is the same, is this, okay? But the risks are not the same. For example, I could have an intruder by here, and probably it's easier to be an intruder here than here, okay? That's the point. So how to come up with some abstraction to analyze these very different implementations of the same process, because we're going to do risk analysis using some consistent model. And we decided to use this abstraction, what we call InfoSec3. Okay, this defined, the first version of this InfoSec3 was used to assure the cloud at the University of Costa Rica. So we started with this model with a larger problem. You know, we had to assure a cloud that is a very large infrastructure. So the way we did this is we defined a tree structure having a whole and part structure. So the root node here is the entire system I want to assure. In this case, it's going to be the application, the software applications we want to assure. And then we start dividing the application in his parts, you know, and you can go to the level of detail that is good for you, thinking from the security perspective. You know, it's at some point, you don't want to do more security for very small pieces of the system. And here, what I am talking about is decomposing, for example, here, the security device, the computer, and maybe other components that I don't want to consider for now. But inside the computer, I maybe have the operating system, for example, and other libraries, and other software, but I am interested here on this element, the application. And then I started decomposing the application in his subcomponents and so on, okay? This way, we can create another diagram, is this one here, that we call information flow diagrams, okay? In this diagram, we select some of the elements of the tree, and we draw the information flows between components, okay? And the nice part is that we are considered the whole structure, but at the same time, we are considering the information transfers between the elements. So it's easy even to create a software to walk through the tree and walk through the diagrams that you define the diagrams as a function of your application, okay? And you can do a systematic processing of the security. And what we did is we decided to analyze risk, threats, vulnerabilities, and even define policies, considering the different elements of the tree and the different connections between the elements of the tree, okay? So the end message in this idea is that if we go in an organized way, you know, step by step, node by node, okay, you can go to the level that is okay for you, and considering all the security steps. So if we move on, let's see. I forgot something here, okay. I'm going to use, for example, this risk here, you know, between the security component, the software component that sends the the summary of the document I want to encrypt, this is the same process we had at the beginning, like we received the document, get the summary, and then here we are going to assign the summary, and we said, okay, let's take this example. I have the software that is going to communicate with the security device. Between the software and the security device, we can have some intruder trying to change the document, for example, the summary. So what we found is that this model represents this case and this case, but the model is the same, okay? So that means with our idea, we could have different architectures for the system where we can do different probability evaluations about the occurrence of the risk, and we could do also different impact evaluations if required, okay? And then we can evaluate the severity of the system. So here's the entire process we use for this analysis. First, we prepare for the analysis. We basically define our goals for analysis. We define the scope of the process, and we define the truth basis. And then, using the tree and the information flow diagrams, we walk through all the nodes that we are interested on, and to identify vulnerabilities, threats, and as a consequence, we get the risks. So after having this in an organized way, we can describe our risk, like this example. For the example I am explaining, we said unprotected communications allow a malicious user to modify the electronic document digits being transmitted from the SCD communicator, this is the security device communicator, to the security device communicator. So the underlining phrases are the different elements we are considering to describe our risk. For example, the vulnerability, unprotected communications, the attacker, the malicious user, modifies integrity control, the document digest is the information piece, and so on, It's like that, and the basic idea is the tree gives us the tool to get this organized step-by-step description of all the vulnerabilities, threats, and risks. And then we can estimate probability and impact. Currently, we are using several factors to describe probability and impact. I'm not going to mention the details here, but in general, we use we calculate the probability based on factors related to the threats and vulnerabilities, and the impact are more related to the information and the business. Okay? And as the preliminary results, because we are still working with the ministry and the bank to obtain the final results, we got this number of risks. We are working mainly on non-repudiation because this is the key point with digital signature, but we also have to deal with integrity, authentication, confidentiality, and probably other information issues. So this is like one of the results, and we already have some preliminary results about policies. Okay? This is an example of the policy we defined for the previous example. Let's say the electronic document to be signed and his intermediate representations must be protected while transmitted over a network so they cannot be modified by unauthorized users. This is for the client-server case. And we have some numbers about the other policies we defined. And the same for the objective controls. And it's interesting because many times you have some number of policies, but you don't have to have the same number of control objectives. And that is good because you don't want to implement all this control. It's better if with one control you can satisfy more than one policy, and that is the case. So, in conclusion, okay, we found that our approach considers a comprehensive and systemic assurance process because it considers the entire system, and the way we walk through the tree and the flow diagram behaves like in a systemic way. So, and we do security requirements, risk analysis, security policies, and objective controls, okay? But the approach also supports a systematic way to identify information security requirements. Actually, we are working now in a software to walk through the graphs we created in a systematic way, to suggest security controls. And also, we consider the system is appropriate for large-scale scenarios because actually we started with something that is harder than our problem now, and we think we are not going to have any issues when going to more complex systems. And the way we are working is appropriate to develop technical guides supporting regulation at a national scale because it's kind of general, it's the objectives we are defining are not very specific to the technology, okay? And we think the approach can improve the quality and security of ICT projects in the context of government services. And for future work, we are going to create, is the next step, actually we are working in this step now, the certification schema, which is composed of some other elements additional to the technical aspects, okay? And we are using standards to do this in a good way. And as I mentioned, we are developing a software system to support the assurance process. And I think now that we have a good result, we are going back to integrate our model with existing security and standards. Maybe we can do some mapping between what we are doing and what is already used in other countries, and maybe we can say, okay, what we should do is this and this and this. But now we know what we want. That's the point. So we did the process to be sure what we want to do. And at last, we think we can extend the model to assure other elements different from information. It's like not just information security, maybe physical device security or other security for other types of things. And that's it.
Thank you very much, Ricardo, for your nice presentation.